Welcome back, all you game designers out there. We're working on our animation and animation states, or part two of sprites and animation. I've got goals for our video today. We're going to be switching sprites using the GameMaker language. I want to make sure you understand what a switch case statement is, and we're going to use that to manage our player states that we set up in the last video. And putting it all together, we create what's called a finite state machine, and it will control the animations of our player based on its movement, basically. We're going to do this all in scripts, and if there's time, we'll add a couple little bonus features. Now, we're doing this as an in-class presentation. I'm going to be presenting this live to my students, and so I'm just going to explain a couple of things. I want to give credit where credit is due. I need to give a lot of credit to Shaun Spalding. He's the one. I knew I wanted to do animation states, and I figured that Shaun Spalding would probably have covered that, and sure enough he did. He's got two different videos that are definitely worth looking at. He's got an animation tutorial, which is where I got a lot of the ideas for the animation. He also has a finite state machine, or just called state machine tutorial. I definitely look at it. But in doing my research and getting things ready, I also went to a couple other sources that are worth looking at. I'm going to post all these in the comment section if I remember. There's one called Coding AI Finite State Machines. And then there's an awesome one that I plan to completely follow one of these days when I have some free time, and that is the Making Zelda in GameMaker. On episode 10, they begin moving things over to a state machine as well. So these are all excellent videos worth looking at. I should also explain that we have this thing called the phrase that pays. I do this for my students because in COVID-19, we're doing this all remotely, and not every day that I present, students are able to make it. They might have other obligations, so I record all of my sessions, and then I give them little hints and tips and tricks that they recite back to me to show me that they watched it. So I've got 5 phrases in here, and I might add some more as we go. So without further ado, let's get working on our game. Okay, so I did go into the room, and I made a couple changes to the scene, and I'll explain why. Let me just go ahead and play it so you can just kind of see how we're doing. The thing about it is, what happened is I noticed that when I jump, I couldn't clear an entire block. I can't jump as high as myself. Now I can fix that in a little bit, and I actually do plan to do it, but I wanted to test this out jumping onto different platforms. So what I did is I went to the grid here, and I actually, by the way, each block and our character is 100 pixels tall. So by changing the grid to 50 by 50, that allowed me to snap wall objects into place in ways that was a little easier so our character could jump from one to the next. Now I could fix that later, but I just thought I would do that for initial testing. So let's go ahead and get the lay of the land. We're looking at our object player, and let's just review sort of what we've got in place. In a previous episode, we talked about doing GameMaker language, and I literally just followed Shaun Spalding's basic platformer game and the first video. So a lot of that stuff comes straight out of there. All of these variables came straight out of there. In our last video, though, we created these enumerators, and we're going to go over those in just a moment. On the create event, that's the create event, excuse me. And then in step event, in the last tutorial, I showed you how to move your code into a script. This is actually calling the script called scr, which is shorthand for script, get keyboard inputs. And so we did all that. Now, if you want to see how we went about it, you can take a look at that in a moment, or you can take a look at it later. But here are, like I said, we're going to be using variables, in particular, the active horizontal and vertical speed, because that's going to tell us, based on what's going on with these two variables, whether we're moving up, down, left, or right. So in the last time we created this enum, and this is shorthand for enumerator, and we call it player states. And I kind of went over a lot of that, so I'm not going to go too much into it. But in my first phrase that pays is about enums. I wanted to define what an enum is. So here's the official definition from GameMaker, their docs. An enum is shorthand for enumerator. It essentially permits you to create your own limited data type with a list of constant values. And it's this list of constant values. Now, if you've taken U.S. history, you probably heard about the enumerated powers of Congress or enumerated powers of whatever. That's a list of actual specific powers. Now, here's the link to it from Yo-Yo Games. We can take a look at that in a moment, but let's look at some examples of what you might do. Let's say you're going to do some software that categorizes the planets in the solar system, or months of the year, days of the week, or in our case, animation states. If you think about it, days of the week, you could pretty much store them, each of the 7 days of the week, or the 12 months of the year, or anything where it's like a finite value. And so we're going to take the enum, which is that list, and we're going to basically determine what are we going to do based on our different player states. So that's our first phrase that pays. So as you see right here, we've created some player states. Our player could be idle, running, jumping, falling, and then we have a new variable called state, and this represents the current player state. And we set it to this value. As you may recall in the last video, we talked about each of these are just basically a number. Okay, so that's what an enumerator is. Okay, so once we got here, we're going to go into the step, and we have this figure out where to move horizontally, figure out where to move vertically, blah, blah, blah. What we're going to do is we're going to create 2 more scripts, and I think it probably we could do this before or after all the movement. But what we're going to do is we're going to basically, let me see what I can't remember what we're going to call it. Hold on a second. Okay, I should have reviewed what our plan is for today. I didn't do that. Here's the plan for today. We're going to create 2 scripts. See, I already mapped this all out. We're ready to go here. One is called scr check state. So we're going to use a switch case statement, and it's going to find out what state are we currently in, and based on it, we're going to be managing our states and running different scripts. So this one's going to call different scripts, and this is going to manage how we go from state to state. This is going to go inside of each of our other scripts. Okay, so we're going to create those scripts. We're going to test our state machine. We're going to adjust the origin of the sprites because that's going to help our moving left and right. We're going to adjust their collision mass, and honestly, this is really going to be key to keeping it from looking really weird. Once you do this, this will be really helpful. And if there's time, we're going to adjust the switching of directions. And we're going to animate the jump and falling sprites to animate just to the final frame, and I'll explain that when we get there. Let's go ahead and create our scripts. One is called scr check state. I'm going to just copy it right here, and it's going to have our switch case statement. Okay, so we're going to check our state. And I'm actually going to call it before I write it. So right away it's purple. It should be orange, but that's because it thinks there's some weird function called scr check state. It doesn't know yet that we're going to have a script. So now let's go ahead and create that. So we create it. I'm going to name it right there, scr check state. All right. And now I'm going to put on here, use a case switch statement to check what state we're in. And we're going to use that I'm going to use it to call our player state scripts. Okay, so we're going to use a case switch statement, which brings me to my second phrase that pays. On my second phrase that pays, I'm going to give you the switch case syntax. Okay, so phrase number 2 has to do with switch case statement. And so what we do is we have this keyword, it's called switch, and this sets it up. We need parentheses, and we're going to stick a variable. This has to be an integer. At least as far as it might, actually, I shouldn't say that, but I know in many programming languages it has to be an integer. In our case, it will be an integer, and I'll explain in just a moment. And then we have different possible cases. Well, in the case of this, we're going to do something, and then we're going to break out. If the case happens to be this, we're going to do this, etc., etc. And this may sound very confusing. So let's just use this, and hopefully you'll understand how switch case works. It's basically, you can almost think of it like as a series of if-else statements. If it's this, do this. If it's not, do this. If it's not, do this. If it happens to be this, this is what we'll do. It's a fancy way of managing our code. So we're going to type switch. And then what is the case that we're going to be switching through? All right, in this case, it's going to be state. Remember, state is that variable that represents the current player states. So it's going to check to see what state we're in. See, that's what we're saying. So we're basically going to do structure. Now, okay, what are our possible cases? Well, our possible cases are all the different states that we set up in the beginning. So we're going to say case, and it was player states dot idle. Okay, well, if it happens to be idle, this is what we're going to do. Now I'm going to tab over, and I'm going to call the player idle script. And I'm just going to select it out of here and do that. Now, there may be a case I want to do something else if we're happen to be in the idle state. And so I reserve the right to add more instructions, but for now, that's all I really have to do. But let's say this happens to be the case. It happens to be idle, so we're going to run that script that's over there. And at that point, we shouldn't be even thinking about anything else. We want to basically break out of this whole structure, and we're going to be done running this particular code. So we're going to go ahead and do this for all of our other possible states. And so you're going to want to make sure that you do this for all of them. So we had idle, and let's just do it in the order in which they appear on here. Okay, let's falling. And I'm going to tab. Now, tab was completely up to me. Look at that, player falling, and then it's break. So this is the way we do this. So we're just kind of basically going through all the possible different states that we could be in. So we've done idle, we've done falling, we're going to do jumping, and we're going to do running. And in fact, you don't have to see me code this. I'm going to pause code it, and then you can pause it when I'm done. In fact, here, I just did the next one. Why don't I pause here, and why don't you finish all of them? You pause the video, and you try to make sure you match all of the switch statements, and you got it exactly the way I am about to do it, okay? Pause your screen. Once you, well, actually, don't pause it yet. Go code it, or pause my video, go code, then come back. You can pause now. Okay, I assume you're done pausing, and this is how we do the last one. And there you go. So in the case of running state, we call the running script, and then we break out. So this is our switch case statement. And so it's a way of just checking all the possible different states. Now, I honestly, maybe we could organize this differently. Only time's going to tell whether what I did was the most efficient. But at least this is one way of managing states, right? A switch case is perfect for managing states. Okay, so what we're going to do is I have come to the conclusion that in all of our different whatever state we happen to be in. Let's just take a look at the script for player idle. Remember what we did last time. We did this little thing about the sprites, and we talked about what states can we change into. We have jumping, falling, running. I am going to go off the assumption that we could go from any state to any other state. Now, that is up to me, and this may need to change. So I might do something that's going to cause more problems. But if I figure I could go from idle to running, from idle to jumping, from idle to falling, let's say a platform disappears underneath me, that could happen. Okay, so I've realized I actually did a live session yesterday, and I realized that I kept repeating the same stuff over and over again. And I realized what I really want to do is I just want to manage my states. Manage, and I'm going to put on here my transition to other states. And we're going to do that using our script scr manage states. I'm going to call it first, and then we're going to code it. And let's just see if that is indeed what we're going to do. We're going to call it manage states. Yes, perfect. Okay, so let's do it. Okay, so we call this scr manage states. So now I want to copy it. So the manage states is going to be all the different states that we could go into. So I'm going to go ahead and right click and create another script called manage states. Okay, manage the transition into any possible state. Okay, to idle. Okay, so if we're going to go into the idle state, we're not moving in any direction. Okay, so I'm going to do an if statement. So this is going to be a series of if statements. All right, how do we know we're not moving? Okay, well, our vertical speed, remember I told you we're going to do this. If our vertical speed is equal to 0, but not only that, not only are we not moving up or down, but we're also not moving left or right. So I'm going to put a little double ampersand, and the horizontal speed is equal to 0. Okay, if that is the case, we are in our idle state. So I put state equals player states dot idle. That's it. Done. Don't have to do anything else. There we have it. Okay. So now we're going to do jumping. Okay. So in jumping, we are basically, we could be going straight up. We could be going up and to the left. We could be going up and to the right. But the big key here is our vertical speed is going to be in a negative direction. And remember, 0 of y is the top of the screen. And so if we're heading towards 0 from any number that is a positive number, we're going to be lower. We're going to be going less than. So that means our vertical speed is negative. Okay, so we're going to do an if VSP is less than 0. And then we're going to put our state equals player states dot jumping. Falling would be VSP. I'll just put positive VSP. So then it's an if, and I like to put a little space there, if it's greater than 0. And we're just going to change the state there, equals player states, jumping or falling. Okay, and then now we're going to be running. All right, left or right. So if we are running, here's what we have to do. We have to, okay, first of all, you should always be thinking when managing states, we need to set up our conditions so that it can never be, like we can never have confusion over are we idle, jumping, or falling. So in the case of running, we are going left or right, but we are not moving up or down. Okay, so you have to have basically mutually exclusive states. Okay, the whole point is you can only have one. You cannot have confusion here. So you can do another if. And in order to do this, we're going to talk about whether we're moving left or right. So in this case, I could put HSP is greater than 0 or HSP is less than 0, or I could do HSP is not equal to 0, but instead I'm going to use this handy little math function called ABS. HSP is greater than 0, and BSP is equal to 0. Okay, and I'm going to explain this in just a moment. If that is the case, state equals player states running. So we have idle, jumping, falling, running. We've got all of our states here. But let's explain this little function here. What are we doing here? And that's what my phrase that pays is about. So the next phrase that pays is about ABS. And that stands for, in this case, ABS. HSP gives us the absolute value of HSP. If you remember that from math, absolute value means it takes a positive or negative integer and makes it positive. Or keeps it positive. So in HSP, and I think 4 was the key number of horizontal speed. So if it's negative 4, it becomes 4. If it's positive 4, it remains 4. It doesn't change. So that way, we can just say, all right, well, if the absolute value is greater than 0, we are going left or we're going right. And then, so then we just put it in the running state. And that's it. So we have our state manager. Now, let's just see if our animation is going to work now. So go ahead and test it out. Takes a while. Oh, uh-oh. Our animation, something is wrong with our animation. Basically, she's not going into idle state. Vertical speed is equal to 0, horizontal speed equals 0. Why is this not working? I know, I just figured it out. But sometimes you have to test, right? To make sure things are not working right, or working right. So what state are we in? I think we're in jumping, right? No. I'll tell you which one we're in. No. Now, remember in idle, we did this manage my transition to other states? We were falling is what we were doing. Because the first thing that happened when we were in idle is we began to fall because we weren't standing on a block. So we went into falling state. We managed our state, but when we were in falling, there was no way to get out of the falling state because we weren't managing it. So this is going to be a phrase that pays. Oh, wait. No, we're going to come back to that a little bit later. We're not going to do that. But let's just copy this and move it into all of our other states. And we'll do that to jumping. And we'll do that to falling. And now let's see if all of this works. Now, if you're using Git and you've been tracking your project and you've got success, this is a great time to commit. Okay, interesting. She's trying to do a jumping, and I can see it's trying to do some animations, but it's doing some weird things. Especially the running. But let's just stop, and eventually it stops and we're in idle. So it's working, it's kind of working, but it's not exactly working. All right, so it's really important here, make sure the manage state is called in all of our different states because this manages the transition to other states. It's a very important thing, so make sure you test all this out. So the real key here is you're going to have to be thorough. So what the heck is going on with our animations? This is where I began to suspect it had something to do with all of my sprites. And I did a little research and I found out. So we tested our state machine. We're going to do the origin of the sprites, and I'm going to explain that. So in the origin, right now, oh, I must have changed it at some point, but let's just double check. In all of your sprites, make sure you set them all to top center. And here's the reason why. When you are running to the right, we're going to flip it so it goes to the right. We want to run to the left. We're going to flip it so it goes to the left. And we're going to want to flip around the origin. And by putting it at the center, it'll make it so that it flips more seamlessly. Okay, so the origin has been changed to top center in, it looks like, all of them. Great. That is good, but it's still doing some weird things. Well, it turns out on my collision mask, we had some issues, and it had to do with the fact that all of our sprites have a different width, right? And our settings of our sprites. And I discovered that if we change all of our collision masks to full, so we do full image, let's try it. player running, collision mask, full image. Instead of automatic, we're going to do a full image. I think part of the problem is when we're animating, like, let me just give you an example. Notice how she's up off the ground for a little bit. If I make that automatic, is this the one? I don't know. Well, we're just going to make them all automatic, all full image. And I'm pretty sure this is what's going to solve it, but we're going to double check. Yes, falling. Notice there's a little gap there. Full image. So they're all full image, and let's test it out and see if it works. Sorry, it takes a while to test. Oh, it's still doing it. Okay, well, I thought I had solved the issue. Okay. All right, well, it's not quite working. Let's just keep going with where we're going, and I'll see if I can find a solution for it. I thought for sure I had that one. Okay, well, I didn't. So let's keep going, though. Let's see what time I've got. 26 minutes in. I try to keep these 30 to 45 minutes, so. And I thought that was going to work. Oh, I'm so sad about all that. Collision mass, switching the direct. Okay. Okay, so let's just go ahead and do step 5, and let's deal with switching of directions, and we'll do the animate the jump and falling sprites, and that may have something to do with it. I'm not entirely sure. Okay, so the switching of the directions, and let's just take a look at left and right. Sorry. Run it again. Now when I'm going to the left, she's not facing the left. So we need to change that. So that has to do with running. Okay. We're going to orient our character to face the direction she's running in. Okay. So we're going to put if HSP is greater than 0. What we want to do is it's an image X scale. Image X scale means its size, the size of its width. If we set it to 1, it's going to be normal width. Okay, it's like take whatever the X size of it, whatever its width is, multiply it by 1. In other words, it's exactly its original width. Then I'm going to do an if HSP is less than 0. I'm going to make it equal to -1. Let's go ahead and test it out. There we go, facing left, and it stays facing left. There we go. Okay. I wonder if the jumping and falling has part of it. Okay, but notice now my sprite player running seems to work. It flips left to right. It's only when the horizontal is going to change that we're going to move to the left or the right. So that should help with the running and jumping, or even with the jumping and falling. Let's do the next step. I wanted to work on the script of the jumping and falling sprites. And for that, we're going to come back to the idea of the image index. Okay, so if we're jumping, I want to basically cycle through each of these, but then stop on the last one. Okay, so we're going to see if we can do variables on here. But in this case, this is the image index, right? And we already dealt with it earlier. This is 0, 1, 2, 3, and 4. So we're going to say if it's greater than 4, we're going to set it to 4 as long as we're jumping. And let's see if we can get this working. Sorry, I got to go back to Game Maker. Jumping. Okay. Then we're going to put a cycle, or I'm just going to put stop animation on final frame. So I'm going to put if image index is greater than, let's see, do we have an image number? I think this is what we need. I'm going to double check online about image number. I'm going to type GML. I'm going to paste that in. Image number. Yo-Yo Games doc returns the number of sub images of an instance sprite. Perfect. In programming, a lot of times the image number is the same as what's called the length. So if that's the case, and I like to use my curly brackets all the time. I technically don't have to, but I'm going to do it here. Image index equals image number -1. And you have to do the -1, and the reason why is image number is going to be 5, right? So let's say we're jumping. All right, we have 5 in all. So image number is going to be the number 5. But remember I said this first one is 0. So if that's 0, this would be 1, 2, 3, 4. So it's actually the number -1 because the first one is always 0. So that's jumping. Okay, so this would stop animation on the final frame as long as we are jumping. And we're going to want to do the same thing for falling. So I'm just going to copy this and try it out in falling. Let's see if it works. I'm going to save our changes and run it. See if we're right. I think the best way to find this out, I'm really annoyed with that. Nope, she's still animating as she's falling. So that doesn't seem to be working. All right, hold on a second. All right, we're going to try something out here. I just want to see what would happen. What if I just only use the last image frame? And I'm going to copy this. So now I'm going to say just image index equals image number -1. So we've already changed our sprite index. And let's just copy that and try that. That's in falling. Let's try it in jumping. Oops, wrong one. I'm going to the, let me just hide that. I'm less likely to do it now. And I'm going to save my changes. Let's try it out. I noticed with the jumping, there we go. Okay, so we can see that it's freezing on 1, and I kind of like that. I kind of like her jump. It's kind of cool. We just have to figure out this whole thing. We're going from falling to landing and running. We have an issue with this. Okay, let's try. I might have to come back. Okay, I think I see the problem. Notice the heights are different. That's 100. And now it's 104. Okay, so let's change all of them to 100. Make sure the aspect ratio is checked. I bet anything that's it. How did I miss that? Because remember, it's when we're falling. Yeah, I bet anything that's it. Let's hope that's right. Well, I guess running is the same as saving it. Oh, please work for me. Please, please, please. You've got to work. Dude, it works. Uh-oh, but it's not working here because our width. Huh. We have a width of 73, a width of 58. Okay, so one of the things that, and I realized this is going on in the last video, is the width affects collisions with the left and the right, and the height affects collision with up and down. So maybe if all of our collision masks are the exact same dimensions, we should be good. Okay, I figured it all out. What I did is I went in and I edited all the images to be 72 by 100. And I believe jumping and falling was 73 pixels. And so an idle was like 58 or something. So I clicked in size, and then instead of scaling the image, which would change the height and the width and some of that stuff, I went ahead and I did a resize canvas. I clicked here and I made sure this was in the center, and I just changed the width and the height, 72, 100, so that they would all be the same width and height. And then I made sure that the collision mask was the full image. Now, I might be able to adjust all the image masks to be more narrow if I wanted to, as long as they were all the same. But let's just show you how it now sort of works. It's not ideal. There are some issues that probably will need to be fine-tuned. But as you can see, as she's running, she's doing pretty good on there. Although it looks like she's sort of hovering above the ground. She is a ninja after all. But you notice how I get right to the edge and there's no weird little animation except for maybe when I jump and I'm switching. This is a problem. And this has to do with the collision mask, right? It's a bit of that coyote physics. But it should only you should only allow her to get out here if you're doing it that way. So remember how we did that 1 pixel trick in the earlier tutorial that Shaun Spalding went over? That we might want to do something similar to that. Whereas if we're at even a little bit here, at a certain point we want to basically fall to the next level, but we'd almost need to fall forward a little bit. That is going to take a lot more technicality to figure out. So at this point, we're basically done. I just want to finalize one last phrase that pays. And the final phrase that pays, and this is a really important one, is that animation states work best when all sprites are the same dimensions. At least in the case of this, the way we've dealt with it with the game maker. So all animation states work best when all sprites are the same dimensions and the collision masks are the same. Okay, I tried one last thing before I go. I played around with the collision masks, and for all of my sprites, I made it a left of 20, a right of 50. So it's only 30 on each, and you can kind of see that as you look at the collision masks on each of these. Let me just zoom in a little bit. Oh, it's going the wrong way. There. You can see there, it's very narrow, and it goes the same on idle and jumping and each of those. And you can see that what it's going to do is it's going to make it so on the collisions, it's going to be a little less, there's going to be parts of the sprite you can see on either side. But let me show you what that looks like when I go to test it out. You'll see that it falls off the edges a little bit better. If you look right here, it's a little more natural. It kind of feels that way. The only thing is that when you collide with it, you can see there is an overlap of the sprites. There are other solutions for this. In fact, one of the ones I've seen on platformers is invisible blocks that are pretty thin lines that you can adjust with sprites. I have another tutorial that covers some of that. So there are ways around this. Right now you can fiddle around, and the key, of course, is just make sure that the collision mask is consistent for all animation sprites of your character. It's always going to be the same, and then you will avoid the issues we were seeing early on. Okay, so that wraps it up for this, the part on animation states and animations, pretty much done. I'll see if we can come up with some other ways of expanding. It would be fun to add some other states, maybe add a second character, add some battle, kind of like a Smash Bros. Kind of system. So I'll probably play around with it. I wouldn't hold my breath for the next tutorial related to this anytime soon. It's going to take me some time to figure out what I want to do. But thank you so much for watching. Do stay tuned for other videos coming forward. You'll see when others get posted. Thank you so much for watching, and stay tuned for more.